We're going back to review the high voltage battery codes, the block codes in particular. This tells us we have 20 blocks. Now looking at the right, we can see that a block is made up of 2 bricks, which is a nickname we gave a group of 6 cells. You see one on the right's positive, one on the right's negative. Total, these 2 blocks, or 2 bricks in a block, will have 12 individual cells. And those cells should produce an output voltage. Our 14.9 to 15.2 has a couple cautions. We have to have no load and be at a normal state of charge. So we start off by looking at state of charge first. Then we go look at the voltage. State of charge has to be between 50 and 68. Looking here, we have 55.2. That's perfectly normal, which says as long as you don't have excessive current draw, which we'll look at later, this is fine. We can now judge our batteries. So we're going to be looking for a 14.9 to 15.2 with a max difference of 0.3 of a volt. Now you may ask yourself, why are we so concerned with a 0.3 of a volt difference in voltage? Here's why. All the cells, all the batteries, all the blocks, ever how you want to look at it, are all connected in series. And all the current to power up the motor, all the current to recharge the batteries from regenerative braking or whatever, is going to have to go through each individual battery. If the chemistry is different in one of the batteries, the voltage will not respond the same. We will get more detail on this later on when we go to the diagnostics. But looking here, it tells us that we've got 0.2 of volts between the highest and the lowest battery block. That means that the chemistry in all those cells are almost identical, very close. And this is a fairly high mileage battery. Now this is a test you can offer customers utilizing your scan tool that can tell them the state of charge of their battery and how good the battery balance is, which tells you how good the chemical balance, the chemical activity of their batteries are. So this is normal, what we're looking for. And now, just below that, we see temperature. We got to talk about temperature a bit because we've got to keep these battery packs cooled down. If we don't, it's going to shut off at 138. Now, this shutdown at 138 is a very rare occurrence. We normally see it in the southwest, one of those 110, 115 degree days where the car sits for a while. That's why the new Prius 3 has a ventilator that powers up off of solar power and keeps the car cooled down just to keep us out of this situation. But our voltages here look normal. But let's talk more about these coolants because these fans are going to run in a particular manner. The hybrid control module is going to start the battery cooling fan at 77 degrees F. But the fan will only run when the vehicle's in motion to reduce noise in the passenger compartment. Because remember, when you stop, there's nothing running. So it will keep that shut down. At 122, the control module will say, hey, forget noise. We're going to run it at maximum. And then as we get to our final 138, it shuts the whole system down because it will shorten the battery's life if we use it at high temperatures like this. So our temperatures look normal, and we come to our next thing, battery voltage. 308 volts. Well, if we go back and look at theory, this is where Doc Knoll and I get hyper sometimes. We don't like theory. The rating from the manufacturer of this battery is 275 volts. But we know the voltage is higher after charging. We use a correction factor for this, and we're going to cover it in a few minutes. But first, we want to look down here. Remember we told you we're worried about the 15.1 and 14.9. If we have a normal current flow, we usually see under 5 amps here with everything shut down. If you turn the air conditioner on, one of these that have a high voltage driven compressor, you will see higher current flows. You might want to turn that off. Now, the other thing we've got to tell you, the battery has to be recently charged. You let this battery sit overnight for a while, it's not necessarily going to be in the 50 to 68% range or state of charge. So you might want to drive it around for a few minutes before you do this test. But let's talk about battery voltage and where the scan data comes from. Notice the arrow on the right is pointing to that little wire going down to the wire bundle with a lot of little wires. Each one of those wires is a separate piece of scan data. Each piece of scan data covers 2 bricks, like we've talked so much about before. So If we calculate this by looking at the theory of saying each battery puts out 1.2 volts times the number of cells, remember we said we had 20 blocks with 12 cells? That gives us 240 1.2 volt cells. Multiplying 1.2 times 240, 288. That's close, but not close enough for Doc and I. We like something better than that. So we looked around and said, hey, look, if we look at this thing when the cells are charged after it's been driven, they're 1.25 volts. And we didn't measure individual cells. We looked at block voltage and found out it's 15 volts. Okay. So what we did is we said, let's use 1.25 times our 240, and we got 300. We like scan data that comes out close to what we expect. Now what we're going to do with this scan data is we're now going to take it and diagnose a vehicle with it.